Hydrogen peroxide. Beta, we have studied dihydrogen with dihydrogen as used as a fuel. H2O, hydrogen is in water, which is the most important substance, or which we can say this is the basic necessity of life. So like the water and dihydrogen, the hydrogen peroxide is also an important chemical that is needed to control the pollution and the pollution control treatment of domestic and industrial issue. Means this is used in the pollution control program to control the pollution, this hydrogen peroxide. Okay, so how we can prepare this hydrogen peroxide? It can be prepared by the following methods. First, acidifying barium peroxide and removing excess water by evaporation under reducing pressure, giving hydrogen peroxide. BaO2 8H2O plus H2SO4 give BaSO4 and hydrogen peroxide H2O2 plus 8 molecules of water. Peroxide disulfate obtained by electrolytic oxidation of acidified sulfate solution at high current density on hydrolysis yield hydrogen peroxide. 2HSO4 negative. After electrolysis, it will form HO3SOOSO3H. And after that, we mix it with water, means hydrolysis will be there. And at that time, we will get two molecules of HSO4 negative, 2H positive, and H2O2. This method is now used in the laboratory for preparation of T2O2 from K2S2O2 with the two molecules of T2O, and we'll obtain T2O2. Okay, along with two molecules of KDSO4. In industrially it is prepared by auto oxidation of 2 alkali anthraquinol gives hydrogen peroxide plus oxidized product. In case in this case, 1% of H2O2 is formed. It is exhausted with water and concentrated to 30% by mass by distillation under reduced pressure. So it can be further concentrated at 85% by useful distillation under low pressure. The remaining water can be frozen out to obtain pure H2O2. This is how we can prepare the peroxide, hydrogen peroxide industrially. This is the chamber. Here we have the water air as coolant and the solid surface through which this is like a semi-permeable membrane, or we can say the foam type. And these are the electrode with positive and negative terminal. From here we allow water to enter inside the chamber, and here from this tunnel we just insert water, O2 with high pressure that will go here, and after this we will obtain the aqueous solution of H2O2. This is how we used to prepare the hydrogen peroxide in industries, okay, in commercial level. Now, the physical properties of hydrogen peroxide. The pure state H2O2 is almost colorless liquid. This the pure in pure this it is a liquid substance just like water, colorless. You can't discriminate between water and hydrogen peroxide. If I give you both the things in a glass tumbler, you will not be able to identify, but when you smell it, then you will able to identify the discrimination between the water and the hydrogen peroxide. Melting point is 272.4 Kelvin, boiling point is 4 to 3 Kelvin. Vapor pressure is 298 Kelvin, and at 298 Kelvin is 1.9 mmHg. H2O2 is miscible with water in all proportions and form hydrates H2O2 dot H2O. Means we can mix it in any proportion. There is no fixed proportion of mixing water in H2O2. For example, if I give you that you have to mix 10 molecules of H2O in H2O2. So when we balance the chemical equation, we used to write the number of moles as the coefficients, stoichiometric coefficients, okay, in the beginning of the molecule. Okay, so H2O2 plus 10H2O, and that will be written as 2H2O2 dot 10H2O. So a 30% solution of H2O2 is marked as 10V hydrogen peroxide. It means that 1 ml of 30% H2O2 solution will give 100 V of oxygen at STP. STP means standard temperature and pressure. But this will become different when we'll go for NTP, normal temperature and pressure. Hydrogen peroxide has a known polar structure. It has a known polar structure, and the structure is different. In when hydrogen peroxide is in gaseous state, the structure is different. The bond angle between the hydrogen and oxygen is different. When we go to the solid state, the structure is different. The bond angle between the oxygen and hydrogen in solid state is different, right? Now the chemical, this is the structure. Two oxygen, the red is oxygen and white is hydrogen. So there is a specific angle between the hydrogen and oxygen bonds. So it acts as a oxidizing as well as a reducing both acidic and alkaline media. Means it acts as an oxidizing agent or as a reducing agent in acids as well as in alkaline or basic media. First, we'll go for oxidizing action in acidic medium. That is, you can see this thing. We know this thing that what is oxidation and reduction. First, according to first scientists, it was like donation of proton and means like a removal of oxygen and acceptance of hydrogen. This is oxidation and reduction. But apart of this, sharing donation and acceptance of electron is also oxidation and reduction. Okay, here we don't have any oxygen which is like uh, moving from one end to another end or from one compound to another compound. Here the donation of electron is there, acceptance of electron is there, so that is why this is also known as oxidation and reduction. So 2Fe2 positive plus 2H positive H2O2 gives 2Fe3 positive and 2H2. PbS plus 4H2O2 gives PbSO4 plus 4H2O. Reducing action of acidic media is 2MnO4 negative 6H plus 5H2O2 gives 2Mn2 positive 8H2O plus 5O2. HOCl gives H2O2 gives H3O positive, Cl negative, and O2. So these are the reducing actions in acidic medium and oxidizing action in acidic medium. And the agent is H2O2. Okay. Now we'll talk about the oxidizing action in basic media. 2Fe2 positive react with the hydrogen peroxide H2O2. It gives 2Fe3 positive plus 2OH negative. Mn2 positive plus H2O2 gives Mn4 positive and OH negative. Now the reducing action in basic media. Iodine I2 gives H2O2 plus 2OH negative gives 2 moles of 2I negative uh, plus 2H2O plus O2. 2MnO4 plus 3 H2O2 gives 2MnO2 plus 3O2 plus 2H2O plus 2OH negative. Okay, this is the oxidizing action and reducing action in basic media. Storage. H2O2 decompose slowly in exposure to sunlight. Okay, 2H2O2 gives 2H2O plus O2. So in the presence of metal surface or traces of alkali, the above reaction is catalyzed. It is therefore stored in wax-like glasses, wax-lined glasses and plastic vessels in dark. Okay, because when it gets exposure to the sunlight, the molecule get decomposed. Okay, so that is why we used to keep it in dark. But I think when you visit the chemistry lab, whatever you see, you used to see that chemicals are stored in the plastic bottles or in the glass tumblers. Okay, because glass and plastic do not react with the chemical substances easily. So that is why we used to store the chemicals in glass tumbler and plastics. right? Or you can also see at your homes that your mothers or or whenever you get the jams, sauces, and pickles from the market, they are in the glass tumblers or in tetra packs because they contains the chemical substances that react with the storing tumbler. If you just store in the metal, it will react with that and decompose it. And if you want to test this reaction, you can put a spoon in the pickle tumbler and leave it for some time. You'll After some time you'll see that the color or the like structure of that spoon is changed, because you'll see some holes in that, because it get react with the chemicals which are present in the pickle and it get decomposed. Okay, it is kept away from dust because dust can introduce explosive decomposition of the compound. If you just if dust goes into it, it will decompose like explosive. It decompose like sudden decomposition will be there. Uses: it is used as a hair bleach and as a mild disinfectant, as an antiseptic. It is sold in the market as parent. Okay, it is used to manufacture the chemical like sodium perborate and percarbonate, which is used in high quality detergent. It is used to prepare the detergents also. It is used to synthesize the hydrocurrent, tartaric acid, and certain food products and pharmaceuticals, etc. It is tartaric acid is used to prepare sweets, to prepare paneer. If you just put some tartaric acid in the warm milk, what it just separate the protein from the water. Protein gets separate, or other milk components get separate and from the water. Okay, so and other food products and pharmaceuticals like medical antiseptic creams and so many things, this hydrogen peroxide is used. It is employed in the industries as bleaching agent for textile and paper pulp, leather, oil, and fats. This is also used as a bleaching agent in textile industries, paper pulp, leather industries, oils, and fats. Okay. It is used in the environmental chemistry. We have studied that it is used by the pollution control department to control the pollution. So that is why this is used in the environmental department. Okay. Next is hard water, heavy water. Sorry. Heavy water is D2O. It is extensively used as a moderator in the nuclear reactor or in exchange reaction for study of the reaction mechanics. Deuterium is used as the moderator, like as a controller of the nuclear reactors. Whenever we perform any nuclear reaction, something is there to control it. If it is get uncontrolled, that nuclear explosion will be there. It get explode and destroy everything. So that is why this is used as a moderator to control the reaction, and in reaction in exchange reactions for study the reaction mechanics. Reaction mechanics is like about study about the reaction, whether it is going in forward direction, what temperature it require, what catalyst is needed, means all the things, silly or small things related to the reaction. You can This is used to study that. It can be prepared by exhaustive electrolysis of water or as a byproduct of some fertilizers. So this is prepared by electrolysis of water, as well as it left behind as the byproduct when fertilizers are made in the industries. Physical properties like molecular mass is 20.027 grams per mole, melting point is 276.8 Kelvin, boiling point is 374.4 Kelvin. This is the structure. The structure is same just like as water. To hydrogen, the angle between the hydrogen bonds will be the same. The structure will be the same. That bent structure is there. So when you put the dihydrogen cube, the means D2O cube in the water, what happens? They just sink in. We sink in the tumbler in the water. We generally see that whenever we put the ice cube, because of the density, they floats on the water. But whenever you have the ice cubes of D2O, it's just sink and settle down in the bottom of the tumbler. And this is different with extra neutron. because with hydrogen we see that there is no neutron, but in this case there is an extra neutron. Okay, this is the water that used deuterium hydrogen nucleus with an extra neutron. Okay, this is how we used to prepare this hot water. Next, it is used for the preparation of other deuterium products, just like CaC2 plus 2D2 O will give C2D2 plus CaOD2. SO3 plus D2O gives D2SO4. AlCO3 plus 12D2O gives 3CD4 plus AlOD3. These are the other deuterium products which are prepared by using D2O. This is used like is as the explosive we have studied for the explosive moderator and fuel cells and so many to control so many chemical reactions. Okay.